to this video session. The topic that we are going to cover in this session is physical properties of metals and non-metals. We will discuss the physical properties of both metals and non-metals one by one. First, we will discuss about metals. The first physical property of metals is that metals are malleable. So children, what do you understand by malleable? It means that metals can be beaten into thin sheets with a hammer without breaking it. Gold and silver are the best malleable metals. Aluminium foils are used for packing food items because aluminium is malleable and can be converted in form of thin sheets. The second property is that metals are ductile. What is the meaning of ductility? It means that metals can be drawn into thin wires. Gold is most ductile metal. Silver is also among the best ductile metals. Copper and aluminium metals are also ductile and can be drawn into thin copper wires and aluminium wires. The next, third property of metals is that metals are good conductors of heat. Silver is the best conductor of heat. Copper and aluminium are also good conductors of heat. But do you know how metals conduct heat? Let us understand this by an activity. Tie an aluminium wire to the stand in such a way with a clamp. Stick a pin using wax on the open end of the wire. Heat the wire near the clamp with a burner. After a while, you will notice that the pin pasted with wax falls as the wax melts. But how did this become possible? How does heat reach from one end of the wire to the other? When a metal is heated, its atoms receive energy and vibrate at greater speeds. This energy is received by the electrons present in the atoms. These electrons move in the metal. When energetic electrons move in the metal, they provide energy to the other electrons and atoms of the metal. In this way, heat is conducted from one end of the metal to the other. The fourth property is that metals are good conductors of electricity. That is, they allow electric current to pass through them easily. Silver metal is the best conductor of electricity. Copper metal is the next best conductor of electricity, followed by gold, aluminium, and tungsten. The electric wires are mostly made of copper and aluminium because they are very good conductors of electricity and less expensive as compared to silver. The next, fifth property of metals is that metals are lustrous. That is, they have a shiny surface and also they can be polished. For example, gold, silver, and copper. The next, sixth property of metals is that metals are generally hard except sodium and potassium. Most of the metals are hard, but all the metals are not equally hard. The hardness varies from metal to metal. Most metals like iron, copper, aluminium are very hard. Although there are certain metals like sodium and potassium that are very soft and they can even be cut with a knife. The next, seventh property of metals is that metals are solids at room temperature except mercury, which is liquid at room temperature. Most metals are solids at room temperature and there is only one metal which is liquid at room temperature, which is mercury. The next, eighth property of metals is that metals have high melting and boiling point, except sodium and potassium, which have low melting point. For example, iron metal has high melting point of 1535 degrees Celsius. This means that solid iron melts and turns into liquid iron on heating to a high temperature of 1535 degrees Celsius. Let's move ahead to the next, ninth property, which is that metals have high densities, except sodium and potassium. It means that these metals are heavy substances. For example, the density of iron is 7.8 grams per centimeter cube, which is quite high. The next and the 10th property of metals is metals are sonorous in nature. Children, do you know the meaning of sonorous? Sonorous means the property of producing the ringing sound. It is due to this property that metals are used for making bells and strings of musical instruments like guitar. Students, let us now move ahead towards the physical properties of non-metals. The first property of non-metals is that they are neither malleable nor ductile. They are brittle. That is, they break easily. Therefore, solid non-metals can neither be hammered into thin sheets nor they can be drawn into wires. The next, second property of non-metals is that they do not conduct electricity and heat. So students, unlike metals, these non-metals do not conduct heat or electricity. Why? Because they do not have free electrons. For example, sulfur and phosphorus. You will be fascinated to know that graphite, which is a non-metal, is a good conductor of electricity. It is the only non-metal which is known to conduct electricity due to the presence of free electrons. The next, third property of non-metals is that non-metals are non-lustrous. It means that they have a dull surface. For example, sulfur and phosphorus. The next, fourth property of non-metals is that they are generally soft, except diamond. The next, fifth property of non-metals is that they can be solid, liquid, or a gas at the room temperature. For example, carbon, sulfur, and phosphorus are solids. Bromine is liquid. And hydrogen, oxygen, nitrogen, and chlorine are gaseous at room temperature. The next, sixth property of non-metals is that they have a comparatively low melting and boiling points, except diamond. The next, seventh property of non-metals is that they have low densities. That is, they are light substances. For example, sulfur has a density of 2 grams per centimeter cube. The next, eighth property of non-metals is that they are non-sonorous. That is, they do not produce a ringing sound when hit with an object. In this video, we studied the physical properties of metals and non-metals. In the next video, we will learn about chemical properties of metals. Friends, welcome to this video session. The topic that we are going to cover in this session is chemical properties of metals. Metals show different chemical properties. Let's begin and study them one by one. The first chemical property of metals that we are going to discuss is reaction of metals with oxygen from air. When metals are burnt in air, they react with oxygen from the air to form metal oxides. These metal oxides are basic in nature and therefore they will turn red litmus solution blue. The vigor of reaction with oxygen depends on the chemical reactivity of metals. Highly reactive metals react at room temperature. A less reactive metal will react on heating, whereas still other metals react on strong heating. For example, 1. Sodium metal reacts with the oxygen of air at room temperature to form basic oxide called sodium oxide. 2. Potassium metal also reacts with oxygen of air at room temperature to form basic oxide, potassium oxide, K2O. There is also an interesting fact about these metals, that is, potassium and sodium are so reactive that they react vigorously with oxygen present in air. They catch fire and start burning when kept open in the air, and this is the reason why they are stored under kerosene oil to prevent their reaction with the oxygen, moisture and carbon dioxide of air. The metal oxides formed in these reactions are mostly insoluble in water. But some of the metal oxides dissolve in water, and they are known as alkalis. For example, sodium oxide is soluble in water and dissolves in water to produce sodium hydroxide, which is an alkali. Magnesium metal does not react with oxygen at room temperature, but on heating, it burns in air, giving intense heat and light to form a basic oxide called magnesium oxide, which is a white powder. Since it required heat for the reaction to occur, therefore, it is less reactive than sodium and potassium. And also, the product is magnesium oxide, which is partially soluble in water, so it is a base. Aluminium metal burns in air on heating to form aluminium oxide. Although most metal oxides are basic in nature, but some of the metal oxides show basic as well as acidic nature. Such metal oxides are known as amphoteric oxides. Iron and copper metal do not burn in air even on strong heating. The reaction of copper with oxygen takes place less readily than that of iron. Silver and gold metals do not react with oxygen even at high temperature, so they are still less reactive. The next, second chemical property that we are about to study is the reaction of metals with water. Metals react with water to form metal oxide and hydrogen gas. Although all metals do not react with water, the intensity of reaction of a metal with water depends on its chemical reactivity. Some metals react with cold water. Some react with hot water. Some react only with steam, whereas some do not even react with steam. A. When a metal reacts with water, hot or cold, then the products formed are metal hydroxide and hydrogen gas. B. When a metal reacts with steam, then the products are metal oxide and hydrogen gas. Potassium and sodium react vigorously with cold water, and these reactions are exothermic in nature, and hydrogen gas formed during the reaction catches fire and burns, causing little explosions. Calcium reacts with cold water to form calcium hydroxide and hydrogen gas. The heat produced in this reaction is less, which is not sufficient for the hydrogen to catch fire. Magnesium metal does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen gas. Aluminium reacts with steam to form aluminium oxide and hydrogen gas. Zinc reacts with steam to form zinc oxide and hydrogen gas. Red hot iron reacts with steam to form iron oxide and hydrogen gas. On the basis of the vigor of their reaction with steam, we can arrange magnesium, aluminium, zinc and iron metals in the decreasing order of their reactivity. The next property that we are about to study is reaction of metals with dilute acids. Metals usually displace hydrogen from dilute acids. Only less reactive metals like copper, silver, gold do not displace hydrogen from dilute acids. When a metal reacts with a dilute acid, then a metal salt and hydrogen gas are formed. All the metals do not react with dilute acids. The vigor of reaction of a metal with dilute acid depends on its chemical reactivity. Metals react with dilute hydrochloric acid to give metal chlorides and hydrogen gas. Sodium metal reacts violently with dilute hydrochloric acid to form sodium chloride and hydrogen. This reaction shows that sodium is very reactive. Magnesium also reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and hydrogen gas. Aluminium metal at first reacts slowly with dilute hydrochloric acid due to presence of a tough protective layer of aluminium oxide on its surface. But when the thin outer oxide layer gets dissolved in acid, then fresh metal is exposed and reacts rapidly with dilute hydrochloric acid. Zinc also reacts with dilute acid to give zinc chloride and hydrogen gas, but the reaction is less rapid than that of aluminium. Iron reacts with dilute acid to give iron chloride and hydrogen gas. Copper metal does not react with dilute hydrochloric acid or sulfuric acid, and this shows that copper is least reactive. From this, we can conclude that the reactivity decreases in this order. In this video, we studied the chemical properties of metals. Hello friends, welcome to this video session. The topic that we are going to cover in this session is chemical properties of nonmetals. Nonmetals show different chemical properties. Let's begin and study them one by one. The first chemical property of nonmetals that we are going to discuss is reaction of nonmetals with oxygen from air. Nonmetals react with oxygen to form acidic oxides or neutral oxides. Carbon forms an acidic oxide, carbon dioxide. Sulfur forms acidic oxide, sulfur dioxide. And hydrogen forms a neutral oxide, water, H2O. The nonmetals are covalent in nature, as they are formed by the sharing of electrons. The acidic oxides of nonmetals dissolve in water to form acids. Let us look at their reactions. 1. The reaction of carbon with oxygen to form carbon dioxide, which is an acidic oxide, and hence it dissolves in water to form carbonic acid. 2. the reaction of sulfur with oxygen present in air to form sulfur dioxide. It is an acidic oxide, and so it dissolves in water to form sulfurous acid. 3. The reaction of carbon with insufficient supply of oxygen. Then it forms a neutral oxide called carbon monoxide. 4. The reaction of hydrogen with oxygen to form water, which is again a neutral oxide. H2 plus O2 results in H2O. The second property of non-metals is the reaction of non-metals with water. So friends, non-metals do not react with water or steam to develop hydrogen gas. Now you must be wondering why? This is because non-metals cannot produce hydrogen gas by discarding electrons and depleting hydrogen ions. The next property of non-metals is the reaction of non-metals with dilute acids. And children, you will be surprised to know that non-metals do not react with dilute acids. For example, non-metals like carbon, sulfur and phosphorus do not react with dilute hydrochloric acid or dilute sulfuric acid. But do you know why non-metals do not react with dilute acids? This is because they are unable to displace hydrogen ions of acids and convert them into hydrogen gas. And as you know, that a non-metal is itself an electron acceptor, and therefore it cannot give electrons to the hydrogen ions of the acid to reduce them to hydrogen gas. The next reaction that we are about to study is the reaction of non-metals with salt solutions. And children, this is one of the most fascinating reactions, as a more reactive non-metal displaces a less reactive non-metal from its salt solution. For example, when chlorine is passed through a solution of sodium bromide, then sodium chloride and bromine are formed. In this reaction, a more reactive chlorine displaces a less reactive nonmetal from its solution. The next reaction that we are going to study is the reaction of nonmetals with chlorine. Nonmetals react with chlorine gas to form covalent chlorides, which are non-electrolytes. They do not conduct electricity. Non-metal chlorides are usually liquids or gases. Let us take an example. Hydrogen reacts with chlorine to form hydrochloric gas. The last reaction is the reaction of nonmetals with hydrogen. Nonmetals react with hydrogen to form covalent hydrides. Let's understand this with the help of an example. Sulfur reacts with hydrogen to form covalent hydride called hydrogen sulfide. Let us look at its reaction. Let us take one more example. Nitrogen, which is a non-metal, combines with hydrogen in the presence of iron as a catalyst to form a covalent hydride called ammonia. Friends, in this video, we studied the chemical properties of nonmetals. In the next video, we will learn about extraction of metals. Session. The topic that we are going to cover in this session is extraction of metals. So children, Before we move ahead with our discussion of extraction of metals, we must know what is an ore. Naturally found elements or compounds in the Earth's crust are called minerals. In some places, there is a significant amount of a particular metal in the minerals, which is beneficial to extract. These minerals are called ore. An ore contains a metal in the form of its compound with other elements. So, after the mining of the ore from the ground, it must be converted into pure metal. To obtain a metal from its ore is called extraction of metal. Now children, ores are converted into free metals by a number of steps, which depend on the type of the ore used, nature of the impurities, and reactivity of the metal to be extracted. The processes involved in the extraction of metals from their ores and refining are known as metallurgy. It involves three most important steps, which are as follows. 1. Concentration of ore, also known as enrichment of ore. 2. Conversion of concentrated ore into metal. 3. Refining, that is, purification of metal. We will now discuss each of these steps one by one. Concentration of ore. As we already know, ore is an impure compound of a metal containing a large amount of sand and rocky material. The unwanted impurities like sand, rocky materials, limestone, mica, etc. present in an ore are called gangue. Before extracting the metal from an ore, it is necessary to remove these impurities. The methods used for removing gangue from ore depend on some difference in the physical properties or chemical properties of the ore and the gangue. By removing the gangue, we get the concentrated ore. That is, it will contain very high percentage of the metal. Conversion of concentrated ore into metal. For the purpose of extracting metals from the concentrated ores, we can group all the metals into following three groups. 1. Metals of high reactivity. 2. Metals of medium reactivity. 3. Metals of low reactivity. We will now discuss each of the three categories one by one. Extracting metals low in the reactive series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar, HGS, is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide, HgO. Mercuric oxide is then reduced to mercury on further heating. Similarly, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating in air. Extracting metals in the middle of the reactivity series. Metals with medium reactivity. The metals in the middle of the activity series, such as iron, zinc, lead, copper, are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide, as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is reduced to metallic zinc. Besides using carbon, coke to reduce metal oxides to metals, sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminium, etc. are used as reducing agents, extracting metals at the top of the reactivity series, highly reactive metals. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. The reactions are: similarly, aluminium is obtained by the electrolytic reduction of aluminium oxide. So children, let us now move to the last point of this extraction process, which is refining of metals. The metals produced by various reduction processes described above are not very pure. They contain impurities, which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Many metals like copper, zinc, tin, nickel, silver are refined electrolytically. In this process, the impure metal is made the anode, and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. The apparatus is set up as shown in the diagram on screen. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Friends, in this video, we studied extraction of metals. In the next video, we will learn about corrosion and prevention from corrosion. welcome to this video session. The topic that we are going to cover in this session is corrosion and its prevention. So children, before we move ahead with our discussion, we should first understand the meaning of corrosion. Children, do you know that if a metal is reactive, its surface may be slowly attacked by the air or moisture from the atmosphere? The metals react with oxygen present in air and form a compound on its surface. The formation of such a substance tarnishes the metal. That is, it makes the surface of the metal appear dull. In some metals like iron, these compounds are porous and gradually falls off from the surface, and then the metal underneath the surface is also attacked by these factors. So, what did you understand about corrosion? The eating up of metals by the action of air, moisture, or a chemical on their surface is called corrosion. Most of the metals corrode when kept in damp air. Let's discuss about corrosion of iron metal. Iron metal corrodes when it is kept in damp air for a considerable time. It gets covered with reddish-brown flaky substance which is called rust. This process of corrosion of iron is called as rusting of iron. Rust is soft and porous, and it gradually falls off from the surface, and then the iron below starts corroding. During rusting of iron, iron metal combines with oxygen in air in the presence of water to form hydrated iron 3 oxide, Fe2O3 into H2O. The corrosion of metals is a highly undesirable process. A large amount of metals is lost every year because of corrosion. Children, now we will discuss an activity to discover the conditions essential for rusting of iron. 1. Take 3 test tubes and place clean iron nails in each of them. 2. Label these test tubes A, B and C. Pour some water in test tube A and cork it. 3. Pour boiled distilled water in test tube B. Add about 1 ml of oil and cork it. The oil will float on water and prevent the air from dissolving in the water. 4. Put some anhydrous calcium chloride in test tube C and cork it. Anhydrous calcium chloride will absorb the moisture, if any, from the air. Leave these test tubes for a few days and then observe. You will observe that iron nails rust in test tube A, but they do not rust in test tubes B and C. In the test tube A, the nails are exposed to both air and water. In the test tube B, the nails are exposed to only water. And the nails in test tube C are exposed to dry air. What does this tell us about the conditions under which iron articles rust? 1. Presence of air. 2. Presence of water. Let us now try to figure out what are the ways in which we can prevent corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing, or making alloys. And what is galvanizing? Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if the zinc coating is broken. Now, what is alloying? Alloying is a very good method of improving the properties of a metal. We can get the desired properties by this method. For example, iron is the most widely used metal, but it is never used in its pure state. This is because pure iron is very soft and stretches easily when hot. But if it is mixed with a small amount of carbon, about 0.05%, it becomes hard and strong. When iron is mixed with nickel and chromium, we get stainless steel, which is hard and does not rust. Thus, if iron is mixed with some other substance, its properties change. In fact, the properties of any metal can be changed if it is mixed with some other substance. The substance added may be a metal or a non-metal. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. It is prepared by first melting the primary metal and then dissolving the other elements in it in definite proportions. It is then cooled to room temperature. If one of the metals is mercury, then the alloy is known as amalgam. The electrical conductivity and melting point of an alloy is less than that of pure metals. For example, brass, an alloy of copper and zinc, and bronze, an alloy of copper and tin, are not good conductors of electricity, whereas copper is used for making electrical circuits. Friends, in this video, we studied corrosion